Alright, so we have the two pieces of equipment to solve the indefinite integral of this guy. R squared, oops, that's messy, minus x squared dx. This one is harder, so be prepared. And by the way, one of those tools is somewhat faulty, and that is trig substitution. But trig substitution is actually somewhat easy on this problem, because after you do a little trig substitution, then it just requires double angle formula, which is okay. So let's have a go. So first step, you want to rewrite the inside, all right? So it's in that 1 minus form, because if you have it in any other form, then trig substitution is not as easy. So let's divide everything inside here by r squared. Though if we're going to divide the inside by r squared, that's the same as multiplying the outside by, dividing the outside by r. And so we have to put an r on the outside. Hey, that's nice. Because now we just have 1 minus x over r, and they're both squared. You didn't see what I did? I divided everything here by r squared, and if I'm going to divide the inside by r, I have to balance that out by putting an r on the outside. All right, step 2. That's 2. Let's replace x divided by r with something usable. Usable? Yeah, that's the word, sure. So let's replace it with, ready? I'm going to use sine. I'm not sure if sine is better. I'd recommend you try cosine and see where you get. Probably a very similar place. So x divided by r is what sine has to be. And what that value, x divided by r has to be sine. So now we have r times the integral of 1 minus sine squared theta. We know that reduces, I'm just writing it out. And then we also have to factor in the derivative of this guy. And so let's do that right now. I forgot to do that. So the derivative sine is cosine theta. All right, and cosine theta d theta, because we took the derivative. And derivative of that guy is 1 over r dx, right? Good. So we have to multiply this guy by r. So this guy is by itself, and we can just bring in, make dx equal to this guy, r cosine theta d theta. R cosine theta d theta. What's nice about that? The r goes on the outside, so it becomes r squared. That gives us the hint, ooh, maybe we're actually working with the area here. And we are. And then this guy reduces to cosine. You can check that for yourself. Cosine times a cosine is a cosine squared theta. D theta. All right. We're actually making great progress here. So now we have our cosine squared theta d theta. Cosine squared theta, as we saw by the double angle formula, there's just one corollary to it. It's that cosine of, ooh, this marker does not like me. Cosine of 2 theta. Yeah, let's choose a different marker. Cosine of 2 theta. See that? Yeah, there you go. Is equal to 2 cosine squared theta minus 1. Yes, it is. And if you want to rewrite it, so you can just replace it with cosine. Cosine squared theta is equal to cosine 2 theta. You add the 1 and you divide by everything by 2. So add the 1, divide everything by 2. Cool. So now let's replace it. And we have r squared is equal to r squared cosine squared theta, well, d theta, you get it, is equal to cosine of 2 theta plus 1 all divided by 2 d theta. All right. So now let's distribute the division by 2. So we get, ready for this, r squared, a giant bracket, because we have an integral here of cosine 2 theta divided by 2. And we have a separate integral of 1/2 d theta. Why did I separate this? Well, this integral is nice. This integral, only kind of. Not really nice. All right, so let's solve the right one first. That's the right step. All right, so we have r squared cosine 2 theta divided by 2. Yeah, let's just use, no, substitution later. All right, cosine 2 theta divided by 2 d theta. That guy can stay. And this is plus integral of half. With anything, it's just because d theta, it's just theta divided by 2. All right, neat. Let's bring this to the next page. All right. Wow, only 5 minutes. Usually this takes longer, I admit. So we have r squared. Oh, darn it, I chose the wrong marker again. R squared times this guy of integral cosine of 2 theta divided by 2, yeah, d theta, plus theta divided by 2. Is it plus? Yes, it is. All right, and that is equal to our integral so far. All right, so this guy, 2 theta, let's replace it with phi. All right, if we're going to replace that with phi, then we have to say that the derivative of 2 theta is just 2 d theta. Derivative of phi is d phi. That's what you get if you go through a toll booth. De phi. Sorry. You have to find something good when you're doing annoying stuff like this. All right, so 2d theta d phi. So let's plug it in. If we're going to do that substitution, we need a 2d theta. In order to have a 2d theta, we have to introduce a 2 here. All right, so now we have a 2 and a d theta. Though if we're going to introduce a 2 here, we have to divide by 2 again. All right, so what does that do for us? Not much. All right, so half. Let's factor out that other half. So now we have a fourth. We have that 2d theta is equal to d phi. And 2 theta is phi. So now we have cosine phi. All right, that's much easier to work with. And now we have theta divided by 2. All right, so now we have, let's switch colors to something a little more classic. Blue. Look at that. Oops, bracket. A quarter, what's the integral of cosine? Well, that's sine. Sine of phi plus theta divided by 2. And you should have an idea that there is a constant attached to this since we're done with all the integral stuff. So we have to say that exists. Let's keep going here. So we have r, we have a quarter. So now the step is, since we took an indefinite, we have to plug everything back in. This is the hard step. It's like you used all these crutches to get through this problem, and now you have to cite the crutches, or I don't know. I'm not really making sense here. So sine of 2 theta is equal to phi, so that's all you have to do with that guy. Plus theta divided by 2. Plus a constant. All right, so now, when did we plug in theta? Sine of theta is x divided by r. Let's use that to our advantage. Sine of theta is equal to x divided by r, which means that theta is equal to inverse sine of x divided by r. Yeah? Yeah. All right. What else do we know? We know... No, that's pretty good. Sine of 2 theta, let's write it a little differently for a second. This will help us, trust me. So sine of 2 theta is same as, if you remember, 2 sine theta cosine theta. If you plug that in, that cancels out with the fourth to give you r squared. And then you plug in. So that 2 fact comes down, so it's now half. You have sine theta and cosine theta. All right, so here you go. Sine of 2 theta is all this stuff. Sine of, well, now let's plug in what theta is. That is inverse sine. We'll cancel this out in a second. X divided by r times the cosine of inverse sine x divided by r. All right, nice. Now we have this theta on that side. That is inverse sine x divided by r, and that's divided by 2. All right, I see a 2 that I can divide out altogether. So we have r squared divided by 2 here. Oh, by the way, notice that with this formula, I didn't have the 2 on that side. So this is technically only the half part of a circle. But that is actually useful enough. So we have r squared divided by 2. And factor that half. So sine of inverse sine, that cancels out to just give you x divided by r. Cosine of inverse sine gives you square root of 1 minus x divided by r squared, or x squared over r squared. If you don't believe me about that guy, the reasoning is, it actually makes a lot of sense. It's all about, so we had cosine of inverse sine. So cosine is the same as square root of 1 minus sine squared. So if you plug in theta as inverse sine into this equation, the signs cancel out and you get x divided by r squared. So plugging in cosine inverse sine of x divided by r is the same as plugging into this square root of 1 minus, that junk. And now it's plus still the inverse sine of x divided by r. And no longer divided by 2. That's nice. All right, and that's basically it. Let's do some factoring. So we can bring in an r here, an r here. If you bring in r here, it just becomes r divided by 2. X divided by r times r. Let's make this half. So let's multiply everything inside times r squared. This times r squared is rx, or you can bring in that. I'm doing a lot of just cleaning up steps. You can bring in that r into the square root, giving you an r here, r squared that is. And r squared times x squared divided by r squared is just x squared. That looks a lot nicer. And then this guy times r squared is literally that guy times r squared. So r squared sine inverse x divided by r. All right, and there you have it. Oh, plus c. Forget that I forgot all those steps where you have that plus c. All right, this is our friendly giant of an equation. How much time? It's 13 minutes in. So here's what we're gonna do. We're gonna prove this. All right, bear with me. Geometrically. All right, this is gonna be fun and not fun at the same time. So this is our ugly formula. Let's check that it's correct. So let's take a circle. We're only using a half circle technically. And every point, if you take a random point, you can make this. This is the area, right? It's this arc part. And it is this triangle part. So if your random x value is x, couldn't put it more simple. This part, if this is a unit, if this is an r squared, if this length is r, then it's an r squared minus x squared. That is the length of this side, right? So the area of this triangle right here is x times r squared minus x squared. That is this piece. Let's color it clearly. All right. That is all this. All right. So we're almost done here. Actually, what is an arc of a circle? It's actually pretty easy. If you're in radians, hopefully you remember this. this angle, it's just the angle times the radius. That is angle and radians, that is, times the radius is that area. And so we're done. And the angle, if you look here, oh, by the way, this guy is divided by 2 because it's a triangle, my bad. Now this guy, it's a little hard to calculate, but you can kind of see it right here. So if you take, to find this angle theta, this is not exactly easy. So you have this length up here of x, you have this length here of r, you have this length here of theta. So let's relate them. Sine of theta is equal to x divided by r. Therefore, theta is equal to inverse sine of x divided by r. Is that true? Sine, yes. All right, if we had used cosine, we would be wrong. So if you plug that in, you get inverse sine of x divided by r times an extra r. Correct? Yes. Plus x divided by 2 square root r squared minus x squared. Is that the same thing? It should be about the same thing. There might be some slight differences. Yeah, there's an extra r there for some reason. Oh, it's because it's the area. My bad. The formula for this, if its area is this. Alright. Yeah. And then we proved it. And this is just a random x that we picked. So in a sense, that plus c is just comes out of the integral if we want to be more precise. So geometrically, this makes perfect sense. You have the sector of a circle. I calculated the distance, not the area. Now this calculates the area. You have to divide by 2 if you're doing that. And you end up with this formula geometrically. So we can be pretty confident that this formula works within the circle. Alright, so we derived it the hard way, analytically. Then we derived it the geometric way. In the next video, we will use this information for good, not evil. Alright, we won't use it to make more people sad that they ever tried this problem and failed. We're going to take this simple result of pi r squared and use it to find the volume of a sphere. It'll be easy, don't worry. Thanks for watching.